Alright, get it. Get it. Shouldn't be very long. It's still going. All right. Well then. I see two squared variables, and they have the same coefficients. So right out the gate, I know circle. So I will group x stuff. Plus 2x. I will group y stuff. And not x or y stuff goes to the other side. So complete two squares. Half of 2 is 1, 1 squared is 1. Half of negative 6 is negative 3, negative 3 squared is 9. And I ask, did I really add 1 and 9 respectively? Yeah. But you do have to check that. Like the number 1 and 2, and it's like a tie, ways that kids screw these up is A, they don't write this over here at all. They just complete square over here and just never add anything to the other side. Or B, they don't add the right thing because they forget about something outside the parentheses. So you got to be careful about it. Then this becomes x plus 1, the quantity squared. This becomes y minus 3, the quantity squared. And that is 16. So it's a circle. I got my form. And then to sketch it, well, I leave it like this. I leave it as x minus h squared, y minus k squared equals r squared. Because if I were to divide and try to set that equal to 1 like a normal ellipse, a squared and b squared would be the same. I wouldn't know which is which. So instead I leave it over there and just say my radius is 4. And if my radius is 4, then I'll have a center at negative 1, 3. And I'll just go 4 units along all of my cardinal directions, my quadrantal angles, if you will, and go 4 to the right, 4 up, 4 to the left, and 4 down. Just to demonstrate what the radius is. Suppose if you really wanted to be technical about it, you should probably just put the radius as 4 on there. But if you got the quadrantal coordinates labeled, I'll be okay. You got to have the coordinates, not just the r is 4. Which means, did you get that? Did you get that? Did you get that? I'm just going to say 2 for the this. Because all your coordinates are screwed if you called it 3, negative 1. Or if you missed a sign on something. But the 3 parts of the equation, you can do basic math on a sketch of a graph. Again, more circular than your typical potato, no diamonds. Okay? How about from the homework? Anything? Oh, that's from the other. You. And you. You. PreCalc, Studente 7. There we go. Okay. Okay, look at the focus. I don't need to have both of them. If I look at the focus and the center, what changed? The y's. So right out the gate, I know that y goes first. Oh wait, this is the ellipses. X minus thing squared is plus y minus thing squared is equals 1. Okay, they gave me my center, so 2, -4. The y's are changing to go from center to focus, so I know that it is stretched vertically along the y-axis. So I'm just going to like make a little note here that a squared will go here. If the focus is 2, -4 plus 2 root of 5, what'd they just give me? I can find my c value because I take -4 plus 2 root of 5. So that tells me c is 2 root of 5. The eccentricity is square root of 5 over 3. But square root of 5 over 3 is c over a. So if that's 2 root of 5 over a, multiply, cross multiply and divide, right? A is 6. If a is 6, a squared is 36. Well, if a is 6 and c is 2 root of 5, I can finish it off by finding b. So c, 2 root of 5, is square root of a squared minus b squared. Square both sides. Remember, when I square a radical with a coefficient, I square inside outside. So that's 4 by 5 is 20. No radical. 36 minus b squared. Subtract, divide by negative, and I get b squared is 16. Okay. But because the y's were changing from center to focus, I know it is stretched vertically. A squared has to go with the y term. Okay. I didn't want to include this before because I think we had just started eccentricity. Okay. Anything else? Cool. Go away. Go away. So we left off, we were graphing hyperbolas. We seemed all right with it. But before we can go do, hey, here's more work, now graph it, show me that we actually can graph it. See, 2b is already in standard form for us. Show me that you can graph standard form of a hyperbola before we have to go making standard form.
So, do you go 8 up and down, and then 9 on the sides? You go times 2 by 2. No. Oh, you just went out. I just.
All right, let's see if we got it. A and B are big. This is a big mamma jamma, so right away I'm just gonna make my whole graph by 2. As soon as I see A and B are 8 and 9, like, I'm gonna make my graph bigger. All right. I've got HK, -1, -4. I've got A is 8, and it's with the Y term, so opens vertically. I'll head down 2, 4, 6, 8 for vertex at -1, -12. I'll head up 1, 2, 3, 4 times 2 is 8. Have a vertex at -1, +4. My slope going to be B over A or A over B? A over B. Y's over X's is the big part. So B is 9. So my asymptotes are Y plus 4 is plus or minus B over A or A over B, Y over X, 8/9. How many of us are using the box? Is anyone using the box to make your asymptotes? Like, I go A this direction, I go B this direction, so it's at 3, 5, 7, 9. 3, 5, 7, 9. Is there anyone doing this? So that you can go through the vertices, the corners of the box. I only had one last hour who was doing that. So I think the box is kind of redundant, but some folks like it. From there, up 8 over 9. Up 8 over 9. There's 3, 5, 7, 9. Up 8 over 2, 4, 6, 8, 9. 3, 5, 7, 9. Down 8 over 2, 4, 6, 8, 9. Shoop. 2, 4, 6, 8, 9. Shoop. There you are. So most of us are probably content with that. All right, I got enough for my asymptotes. If I got enough for my asymptotes and I already have my vertices, then I can make my hyperbola. Whoa, whoa, we're almost there. What are we missing? Foci. So C for a hyperbola is the square root of a squared plus b squared, which is the square root of 145, which, if I remember correctly, does not reduce down. But how far do I go on my graph? Just a hair over 12, right? Very close to 144. So from the center, I go up 2, 4, 6, 8, 10, 12, just a hair over, and say my focus is at -1, -4 plus square root of 145. I go down 8, 10, 12, just a hair more. My focus is at -1, -4 minus root of, there's not a parenthesis here, or a comma there, I swear. Totally a figment of your imagination. Okay. So, graphing the hyperbola, are we okay with that? Because if I can just, practice the complete the square, make it, I would rather do that. But if we need more practice with these, we will. So, this guy was already in standard form. That guy ain't. So just like with ellipses, I'm going to do the same thing. I'm going to group X and Y stuff together, but this time I probably want to pay attention. Who should go first? Which is it? Why? Why the question, not the variable. Why should X go first? There you go. 25x squared plus 100x plus -16y squared plus 96y is, and my constant is already on the other side. I still need to factor out, but boy, do you need to pay attention when you factor this time. Because here, yeah, easy peasy. But what am I factoring out of the next one? And you be careful with that. Year after year, I see kids come along and say y squared plus 6y. They forget I am factoring out a negative. You can tell I'm in full toddler dad mode that I actually use silly goose on a daily basis, unironically. Because it beats saying, you crazy son of a... Yeah. Complete square, be careful that you're actually adding the thing that you said you added. Half of 4 is 2, 2 squared is 4. Did I really add 4? Nope. Half of -6 is -3. -3 squared is 9. Did I really add 9?
No, you subtracted.
I subtracted 144. Okay, it's -16 by 9. That sign You've all known this for a long time. The negative is the bane of the math student, right next to word problems. Okay? Negatives screw us up. Be careful when there's negatives. And I get 25 x squared plus, or x squared plus 25x plus 2, the quantity squared, there we go, minus 16, y minus 3, the quantity squared is 4 Hondo. Interestingly enough, 400 is 25 by 16. So, x plus 2, the quantity squared over 16 minus y minus 3, the quantity squared over 25 is uno. So how about just verbally? Where's the center? Okay. Is this stretched vertically or horizontally? Or open vertically or horizontally?
Horizontal.
How do I know?
X versus
X is positive, all right. How far to my vertices? 4, because I A towards the vertices. What's the slope of my asymptotes?
5/4.
Which is it?
5/4.
Y's over X's. Rise over run. 5/4. And the foci are how far away? Square root of 41. It does not reduce. Ew. Don't say 6.1. What is wrong with you? You've been in here all year.
At least round.
Which is about 6.5 units away on your grid. Okay. All right. So I think you know how to graph them. It's just, can you complete the square them? Y'all seem to be doing quite a bit better than first hour with these. So cross this out. I'd rather you did this one. Okay? I'd rather you did this one. Well, the 2B had only one complete the square on it. This has 2. It's just better practice. There's a reason that I'm only assigning you like 5 problems a night. I want to do the practice in class.
Just do we need to graph it or just?
Don't worry about the graph. Just complete the square on it. I think y'all are pretty good with the graphing part. Most of us.
Is it fine to write down there just to be able to look at it?
If you need it there to make it in the correct form, you have to. Can't just leave it blank.
Just a label. Instead of
Nope. I just want to see if you can do the complete square thing.
what? Yeah.
What's that? Minus 4, minus 6, minus 3. So 3 squared, 9, 9. Negative 36. Cancel, cancel. 4, 2, 4, 1. 4, 1, 1. Yay, nay? Okay, and you do need to have that 1 down there because that is the form of a hyperbola. That bothers me. Like, okay, Chad was asking, do I need to put that 1 there? Because if it's just y squared, we don't put the y minus 0 squared because it's not simplified. So why would I write the 1 there since that's not simplified? But then that's not the form of a hyperbola because you don't explicitly know what b squared is. Like, that bothers me. That really bugs me, but you get the idea, right? You know A and B are, which way you're headed, your slope, all that good stuff. Okay. Sweetness. I don't need any more of those then. So we've done it a couple of times now. You know what's next. Here's the equation, find the features. Here's the features, find the equation. Now we're going to go backwards on it. So remember that my major and minor axis from an ellipse are now called a transverse and conjugate axis. But they're still 2A and 2B. If I see vertices and foci, remember that vertices and foci lie along which axis? I just got done saying it, dude.
Get him up. Just get him up.
I just got done saying it.
Where's our food, Will?
Exactly. Yeah, he doesn't get to talk until he brings food. He gets taxed. Every day now. Every day.
Every day?
Okay.
For finals, Will's just going to spring for pizza. All right. So I'll write out my form first. I've got something minus something squared over minus something squared over is 1. Feel like a little kid the first time they play on a walkie-talkie. Over. But when I see that my y's are changing for my vertices, and they lie along the transverse axis, that tells me my transverse axis is vertical, because it's the y's that are changing. So that tells me y goes first. Additionally, that distance is still 2a. So a is 4. And since I know that this goes first, I know that the a squared goes with it. Even more than that, vertices, foci, doesn't matter. My midpoint is still my center. And that's x2 plus x1, x1 plus x2 over 2, and y2 plus y1 over 2. Or whatever mental gymnastics you want to do. You can say, well, if I subtract that, then that's 8, and then 8 cut in half is 4, so I go 4 down from the 2. I don't care. Either way, you're still getting a center of negative 3, 2. Negative 2. So I still got my h and k. Plus 2 plus 3. And just like with our ellipses, the foci, even though they're not a part of my equation, are going to help me find b. So off to the side. Side quest. C is the square root of a squared plus b squared. I just found out c was 2c is 10, c is 5. 5 is square root of, I just found a squared. 16. We recognize that 3, 4, 5 triangle again. Okay. B squared is 9. So, if they give me double coordinates, it's not bad. Setting up again. This minus that squared over. This minus that squared over is 1. Just like before, I see that my x's are now changing. If the x's are changing, then my vertices lie along the transverse axis and it is horizontal. X's go first. That distance is still 2a. So my a squared is 9. My midpoint of these two is still my center. Halfway between -3 and -9 is -6, 0. I plug in my -6, I plug in my 0. What can I do now? How can I clean this up before going on to that? All right, when I say y minus 0 squared, I'm going to come back and clean that up. And just call it y squared now. All right, the asymptotes. This part's a little bit different. We've got to be careful, very careful with it. If I said that the asymptotes are 2x minus 12 and -2x plus 12, then that means I have a slope of plus or minus 2, which is written as 2 over 1. Is my slope for this particular hyperbola going to be a over b or b over a? Y's over x's, b over a. And I can direct correlate them because I just found out that a was what? So if a is 3, now I want you to think about that. B is plus or minus 6. B squared is still positive regardless. So I'm still going to put 36 on the denominator. But is B really plus or minus 6? What is B? What do I do with B? Like on my graph, what do I do with B? Okay, because it's the what? Distance. The magic word, distance. B is a distance on my graph. Can distances be negative? No. So B is just 6, not plus or minus 6. Just like when we did plus or minus square root of thing, and that was the length of a triangle. Well, I can't have a negative length. So yes, this is 36, but I need to be careful. I need to make sure that everything still lines up. So, I do some, you do some. No, not that. There we go, that.
Does conjugate always horizontal? No. Is that the
Transverse major. Conjugate, minor.
So in this case,
Is it?
yes. No. No. Yes. Wait.
When in doubt, draw it out.
Yes, it is.
So that would be 1 minus 4 minus 3.
I think it's 20.
This one on X is it's really ugly. Oh, just the elevator. Yeah. Thankfully. The conjugate axis length is 2.
How did you get that?
So if I look at a C. So C in the first 5.
Oh.
So we have no Y. That's negative 2. Okay. Oh, yeah. So now we have.
What do you get for the denominator?
Okay, so then.
Which one's first?
Oh wait, I forgot to swear on the 4 and 25.
C over A.
That's okay. That just is. It's not a P or an R, it's a K. Shit, have you seen her full?
I grade her stuff.
They look like H's stuff.
Yep.
Zoe's?
I got a kid in my algebra whose 9s all look like perfect G's.
C over A in this case. And the slope is 3/4.
Okay.
The kid does his like that. That's 9G. I hope all of this arguing about handwriting means we have both the problems done. You always do both.
We just need to find more about it. And then we can set it up.
The slope would be B over A.
Mm-hmm.
So B over A. We just need to take 3/4 out of 13/4. If you 13/4 divided by
Is it plus?
oh, you're right.
How's that donut calendar? How's that which doesn't want to do a vertical line.
Yeah. No. Oh wait. So it's kind of okay. She's still arguing about this stupid thing.
No.
I don't get it.
Oh, you're right.
So
Why? It's like the
X minus H, Y minus K.
Oh, yeah.
Here they say that conjugate. Oh, you're right.
Your transverse axis is the way that it opens. Conjugate is the way it doesn't open. Okay. Check out first one. My vertices lie along the transverse axis. Transverse axis is 2a. So I already got my a for a squared. Because my vertices lie along the transverse axis and they are y units apart. That tells me y goes first. It opens vertically. Conjugate axis being 10 units tells me that the b, 2b is 10. So divide, square, get b squared. And the midpoint between either vertices or foci will get me my center. Now, this one, on the other hand, things get a little goofy. First, my center, my midpoint is going to be 2 plus 12 is 14, divided by 2 is 7. Negative 2 plus negative 2 is negative 4, divided by 2 is negative 2. So I have my center. Normally, foci gets me what? So from here to here, 2c is 10, c is 5. Well, that doesn't do me a diddly bit of nothing if I don't have a or b. But they did give me asymptotes. So I come over here and I say my asymptotes plus or minus 3/4. So I'll just say 3/4. A over B or B over A? Like a friggin' Clydesdale. But is it direct correlation? Can I just say B squared is 9 and A squared is 16? I do have to check it. Because, now yes, the B will correlate with 3, the A will correlate with 4. But what if, instead of 5, what if C was 15? Does 3 squared plus 4 squared equal 15 squared? No. Then I would have to make it 3 times larger, because 9 over 12 still reduces to 3/4 as a slope. Look over here. What do all of these have in common? Every one of these are, when I reduce them, a ratio of 3 to 4 to 5. That C being 5 does help me because it confirms the scale of my slope. So yes, it is actually 3/4. Okay. They weren't messing with us. That is actually going to be 16 and 9. That has not changed. But I have to match it with the foci. If I don't match it with C, like, how does that change things?
Center moves.
No.
It doesn't change the center. It just changes what A and B would be.
C is
How did it not change the center? It does. It still goes up and down the same amount. Oh, I'm just saying it changes like the location. Changes.
it does change.
Yeah. Yeah.
Wait.
It doesn't change the center.
I would change this.
Because it's still, they're both.
Oh, sorry. There we go. That's better.
Now it's different.
I mental math wrong. If I do that, isn't the midpoint between -8 and 22 still 7?
Yes.
So the center is still the same. I still get x's go first. I go over to my b over a equals 3/4, and all of that is good, but now c is 15. If c is 15, that will not make c equal the square root of a squared plus b squared. I have to change the scale of a and b by multiplying by a scalar factor to make it work. It's a small thing, but it's something that pops up, and you need to be careful with it. Hold on, go and think. 05, 18, 05, 18, 9, 9, 81, 81, 75. That's going to be 14, 7, 49, 49, 81, 75, 32, forward. 5 going to be y minus 3 is plus or minus 4 root of 2 over 6. This does not exist.
You're still on my paper.
Okay, you are given those foci, and that is the asymptotes. Write your equation. Ah. Oh, I swapped my y and x. Hold on. I did it too fast. Sorry about that.
Okay, so distance between C and we know whatever it is. Forward 2 forward 2 yeah.
Just like this value.
What are we doing?
Muffin. Finally finishing my breakfast at nearly 11.
Which one is? Oh, that's right. 'Cause you have the one
Don't spoil it.
top
I'm not
part.
there yet.
It's not that
Always bad.
It's right there.
Oh, yeah.
Oh, for like the focus.
Saturday has to be over it. Yeah.
There you go.
I got. No. I don't know. How did you find that?
It's 49, so we get 14 squared left for that is
A is the what's that for A? Because if you see how they oh, yeah, something like that. So A, you think A equals 4 squared root 7? 4 squared root 2 over 7. Or 4 squared root 2 and then y. Oh, it's over 7. For sure.
There we go.
49. 232.
All right. Who's first, X or Y?
Thanks, Bobo. I think Jacob is also right. I don't know how you got the 6 oh wait, alphas. 7.
Okay, midpoint. -3, 6. We're good so far.
I changed it. Change that. Why?
So, will my slope be A over B or B over A? Y's over X's. And I know that will be equivalent to 4 root of 2 over 7. But can I just immediately go to square this, b squared, a squared are 3249.
Check with the C now.
I have to make sure that actually works with the C. I have to ensure that if I said C is 9, then 9 better equal the square root of 49 plus 32. If it doesn't, then I have to change what A and B are by doubling or tripling or whatever it is, the scalar factor of it. But 49 plus 32 is 81, so it actually does work. So I'm able to put my 49 and 32 in there. Okay? You have to check it because they will not always work like that. I don't remember which one. I don't remember if it was in the homework or if it was on one of the forms of my test. I know we've come across that before. Okay? So I just got to bring it up now so you're aware of it. All right. Eccentricity. We talked about eccentricity with ellipses. Eccentricity of a ellipse, a perfect circle, is eccentricity of 0. What happens as it stretches out? What's happening to the eccentricity? It's getting bigger, and as soon as those foci go from the center of the circle out to the vertices, what happens at eccentricity equals 1? Line. Okay? So think of it like eccentricity of 0 is circle. Eccentricity of 0.5 is normal ellipse. Eccentricity of 0.9999 is almost what? And when it hits a line, something cool happens. At 1, my foci are right on top of my vertices. But what's also happening is, like, trying to think of where I've seen this. Like, you ever try to line something up in a Word document or something, and if I just twitch the mouse just a hair, it'll pop like from one thing over to the other and try to auto line up with something else where it's just right on that edge, and if I just wiggle it, it just pops over. At 1, what it's also doing is my foci right on the vertices, it explodes outward to straight vertical. And then, as it gets bigger and bigger and bigger, at 1.5, now it's vertex, vertex, focus, focus, out like this. It takes those lines and it straight vertical and it starts bending them like this. So what happens out at 2 and 3 and 10? So at 10, now I'm looking more like this. What's going to happen as it goes to 1,000? A million? It's never going to actually hit a line because is there a limit to it? Now, it'll look like a line. It'll just look like 2 whiskers hanging out in the middle of nowhere. But if you zoom in on it, it's a couple of really skinny hyperbolae. So that's what it does. In practice, eccentricity is still C over A. It's still the same thing. But what is C for a hyperbola? a squared plus b squared. That's what turns it into something bigger plus something bigger than 1. All right, we had some problems last hour. Show me you know how to work with radicals.
Yeah, you're right. 84. Yeah, you're right. 84 over 433. The square root of 84. Square root of 84 over 4 root 3. Right? The square root of 84 is 12 square root of 7. You said 47? Yeah. 40 like my head is 47 number over 4 root 3. Oh. So that's 47 over 47 square root of 74, which divided by why are you getting over 43? Don't worry, this one is square root of 7 over 4 root of 3. I got 3 something that is 12. No, I reduced. What about the 48? You should do 24 square root. Yeah. That's definitely not a very long, complicated way. That's definitely an easier way to do it. So it's not 27.
Yep.
Is it square root 7 over 2?
Yeah. Oh, that's I missed that. 21 should be root of 21 over
4032.
Yeah, I'll do it.
Alright, 3.7? 3 times 7. Oh, another one 3.7.
Oh, I didn't know.
Oh, we still got it right.
They're both in radical land. How about way back here? If I take both of those divided by 3, what happens?
I like this sideways one.
Yeah. Do you see that there's a bunch of different ways to do this? You don't have to overthink it. Try again.
Keep the root of A is 64.
Was it 144? Yeah.
3 over 2.
That one's easy. Oh, really?
And I'm like, hey, that comes out nice. That was awesome. Thank you.
Yep.
This
guy.
Now try it.
If you're gonna change it, at least erase it and not do the little white scribble.
No.
What's
Do the magic. Do the magic.
So what's
I don't like this.
20? Four, 4,800. Now, what about this?
Don't you give me the stink eye while you mental math. Hurts my feelings.
You get root of 30 over 1. It's 2 root of 30 over 4 was 3.
I need to
So root of 30.
No, you don't. I borrowed it out to someone.
And then yeah, that is. You get the. You get the. Poor rice not in it.
Yeah.
40. 2 times. Well, it's the square root of 40, isn't it?
Yeah.
2 root of 2 times root of 5. Cross, cross. We're going to get that root of 3.
I'll tell you one thing.
Wow. 2 root of 4.
Can you use that calculator on the ACT?
Yep.
Yeah. Do you use multiple calculators on the ACT?
You used to.
Yeah.
I just found that out this year. In the past, I've always had kids bring an 84 for function operations, graphing tables, stuff like that. And I told them for just basic arithmetic operations, simplifying radicals, stuff like that, bring yourself one of those $10 Casios. And then this year, I had a kid come and tell me they wouldn't let me have both.
So which one would you choose the 84?
Yeah.
Because of which one?
I would choose the 84 because I got no problem doing all the fractions and radicals in my head, and I know the 84 very well. I would recommend most students who can't turbo out 5 different regression models in 30 seconds, stick with the $10 one. It's going to do you more good.
No, you get the root of 3 over 1.
How about just root of 3?
Which is the root of 3, but.
Whatever. What do you mean you lose to me? I say no, I lose. Yep, I did it all the time.
you got to think about the numbers.
Yeah.
Even when I did that, why did I do that?
Oh yeah, we skipped the example 5 and 6.
Ta-da! How many of us got to Walmart by route of Wisconsin?
Hey, when you have this bad boy,
Y'all, sometimes the big picture is worthwhile. Square root of 120 over square root of 40 is the same as the square root of 120 over 40, which is just the square root of 3. But if we had been working with this nonstop for the last 3 years, we probably would have caught that. All right. Example 5. I can cut it because you're going to do it in trig. Y'all remember discriminant from Quadratic Formula? B squared minus 4ac. Tells you if there's 1, 2, or no real solutions. Okay? You can do something similar with that. See, it turns out that when you have those squareds, what they have not been showing us this whole time is that when I multiply stuff, it is possible I've got an xy term in there. And if I have an xy term, what that does is it rotates your conic sections. And now all the points on it are defined by that rotation, and that rotation is defined by special trig ratios and trig identities. Now, when I go this way, I'm going to have to add in, it's going to be something, something, something plus cosine of something, something, something as my coordinates. Which, since we did not do chapter 5, we do not have that information. You'll do it in a completely separate class. Cross out example 5. Okay, now the discriminant, that is something we can do. It helps you determine whether it's parabola, ellipse, a circle, or a hyperbola. But it's got all those rules with it. You can do that next year. After that, the application of this, you remember all the way back to the beginning of this section, we said the difference in those distances is always equal instead of the sum. What that does is it allows me to say, I got radar, it said that there was a lightning strike that was 8 miles away from this one, 6 miles away from that one. Where exactly did it occur? I can find exactly where it occurred because of the equation of the hyperbola. Again, if I need to cut something, I'm going to cut that because that's in physics, or it should be in physics. Instead, I want you to bust out chapter 6 notes. No, we don't have much time left, but we have enough for, call it the teaser trailer. So the first thing that I would like you to do, just as kind of a warm-up before we hit chapter 6, if you would please, chapter 6, section 1, example 1. I want you to solve that 3-variable system however you remember how. Leave room to do it again next to it on Tuesday. Five, gone. Gone, Y. 1, negative 4, negative 5. 1, negative 4.
yeah, easy, dude.
3 through 3.
It's literally all that my notes are
Gone.
variable 2 ways, solve 2 variable system, go back into zone.
4. Negative 2.
Yeah.
Negative 6. 2, negative 1, negative 3. 2, negative 1, negative 3. 1.
The only problem is, not many variables. I'm gonna put y to 10.
That's only one variable.
One variable.
Get it wrong.
I'm not gonna use it. Take this.
Times negative 2 is gone.
Take this.
4 is 8. It's 12. 8, 12.
Yeah, one. Yeah. Top 1 by 2. Make sure you multiply.
It's actually 20z.
4.
Negative 5.
Negative 60. Minus 10.
What the heck? You should go to here.
Equals
6, negative 6. 15. 1, right?
5x minus 5z. I got that one. Up here. Then we do the same thing again.
Y equals 1.
Or you have them multiplied and then you add them?
Yep.
Yeah, you did. Okay.
No, it doesn't. Negative 1, 1. 1, negative 1, 2, 9.
Yeah. No, they are cancels. Oh yeah.
Why is it negative? Sorry, 10x minus 10y. Okay, why do you negative 1? I'll show you this thing. Did you see this?
I think you put everything on one side for both of these and then set it equal. Like that. Oh, he's doing matrix all day.
Actually, one positive 7 or negative 7?
That's
Well, you need to do
that makes Magic.
I got 7
So -4, 16, 14.
That's also what I got?
No.
We did libraries.
I was looking up here, and I actually messed up on the very bottom. All it does is do
7.
Consider that your preview.
What the heck? No.
Oh, that looks funny.
That looks easy. Or than this.
Well, I multiplied these equations by 2 and 5, and then I just like add them together, but I did something wrong. Oh, no. Now I don't know.
Consider this your preview. Are you the chosen one? Can you see the matrix? See, our Algebra 2 usually doesn't introduce matrix operations. Every now and then we got a teacher who will, you got a little bit of time, you got 20 minutes at the end of 3 variable systems, and they'll just kind of show you the skeleton framework of this. And kids are like, oh, hey, that's not bad. But we don't really take our time with matrices until chapter 6. But this isn't Algebra 2 standard. We are, that's where we're going to pick up on Tuesday. Remember, Monday is quiz on chapter 7. Tuesday we'll pick up 6. We did miss a full day in chapter 7. Not happy with it. I might have to cut inverse matrices. Maybe irreducible partial fractions. I'm going to go talk to Mr. Spear and see if he needs that stuff for pre-calc or not, or calculus or not. If he does, we're going to have to squeeze something in, like maybe miss that day of in-class review.
Say we have a teacher.